Alright, I've redrawn the figure for you. Here's y equal to x, y equal to x squared, the original x and y coordinate system, the rotational axis, and the volume of rotation. So pick an S perpendicular to S, take a cross section, we get two circles, an inner circle and an outer circle, and join the S point to where the inner circle meets the region, which is up to here. And for the inner circle as well as the outer circle, so the inner circle radius is R1, the outer circle radius is R2. For now, I'm just gonna worry about R1. So we have to figure out how R1 is a function of S. And this then is simply the disk procedure all over again. So we pick this point, we draw the rectangle, and in the rotational coordinate system, its coordinates are, they're R1 comma S. R1 is the X coordinate. In the original coordinate system, we need to give it some coordinates. Now we're going to have to give coordinates for this point and that point. So we have to be a little bit careful about giving them different sets of coordinates. So I'm going to call its coordinates x1 comma y1. And that rectangle is this. So this is x1, this is y1. And let's write down the basic relations now between SR1, x1, and y1. And they simply are S equals y1. R1, which is all the entire distance from here to here. X1 is the distance from here to here. So R1 is this distance, which is 1 plus x1. R1 is 1 plus x1. And x1, y1, the point x1, y1, because it falls on this line, is related by y1 equals x1. And now we can figure out how R1 is a function of S. So since R1 is 1 plus x1, x1 is the same as y1. This is 1 plus y1. y1 is the same as S. So this is 1 plus S. Okay, so we got R1. Now we're going to do the same thing for R2. And just to make this a little bit simpler, I'm going to draw a different diagram. I'm going to repeat the diagram so that we can do this for R2. Okay, so pick a value of S. For that S, draw the washer, the two circles. That all the way out to there is R2. So let's draw the red rectangle for the rotational coordinate system coordinates, and the coordinates are R2S. Let's suppose that in the original coordinate system the coordinates are x2, y2, and that's in the original coordinate system. This is x2, this is y2, and then again S equals y2. R2, which is all the way out to here, equals x2 plus 1. So R2 is 1 plus x2. And on this point, x2, y2 have to satisfy the equation for this curve. So y2 is x2 squared. Okay, so I have 1 plus x2, and x2 is then square root of y2. y2 is s, so this is 1 plus square root s. So now we have both r1 and r2 in terms of s, and we can calculate the volume. We need one more thing. We need to figure out what the limits of integration are for s. So s is the same as y1, which is the y coordinate of this curve. The smallest y coordinate is of course 0. The largest y coordinate is where that curve intersects that curve, which means we have to solve y equal to x and y equal to x squared to get the coordinates of this point. And that comes down to saying, let's solve y equal to x, y equal to x squared. So x must be equal to x squared at that point. If I move x onto the other side, I get x squared minus x, which is of course the same as this, which means either x is 0, which of course corresponds to this point. The two curves in fact intersect here, or x equal to 1, which must correspond to this point. So if x equals 1, y is also 1. So the coordinates of this point are 1 to 1, which means the limit of integration, the values of y, range from 0 to 1. And so v is 0 to 1 pi the larger radius square minus the smaller radius square ds, and that of course is pi 0 to 1 r2, which is 1 plus square root s squared, minus r1, which is 1 plus s squared ds. And now all we have to do is just figure out what that integral is. So that's pi 0 to 1. If I expand this, I get 1 plus 2 square root s plus s. If I expand this, I get 1 plus 2s plus s squared ds. And let's see what that works out to. So that's pi 0 to 1, 1 plus 2 square root s plus s minus 1 minus 2s minus s squared ds. The 1 cancels with 1, minus 2s and s gives me a minus s. So this is pi 0 to 1, 2 square root s minus s squared ds. And that integral is fairly straightforward. So again, remember, s square root of s is s raised to half, so that integral is 2 s raised to 3 over 2 over 3 over 2. This is minus s squared over 2 minus s cubed over 3, and that's it.